Okay, good morning. So today we're going to be working on scheduling algorithms, which is one of the responsibilities of the operating system to be able to schedule CPU time. So before we get started, it says your teacher will run this activity for activity 1. I would like to schedule, well, I'd like you to schedule your day. So can you break down what you intend to do, what you would like to do, and what you have to do today? So make a task list. And I would like you to estimate how long you think it would take. For example, eat breakfast is a very important part of the day. And for me, it takes about 20 minutes. It could be get to school. It could be lesson 1, lesson 2, lesson 3. It could be homework. It could be watch Netflix. It could be, I don't know, whatever it is that you do in the day. Give me a list of tasks and tell me in minutes how long you think each one will take, please. Fab. So today we're going to look at what an operating system does in terms of process management, what a process is, and how they need to be managed, I guess. So an operating system uses scheduling. Scheduling means prioritizing your time, splitting your time, sharing your time, to give each access process a share of CPU time. Well, what does that mean? CPU time just means the processor can only do one thing at once. Well, that's not quite true. An individual core of a processor can only do one thing at a time. If you're running lots and lots of apps on your taskbar, then the user needs to think that lots of things are happening at the same time. So we need to pretend that you're doing multiple things at the same time. How do you do that? You do that by saying, right, do Word for however many milliseconds, let's say 64 milliseconds, then switch out to PowerPoint for 64 milliseconds, and then switch out to Windows for 64 milliseconds, and then switch back to Word and keep swapping between them. So split your CPU's time into segments. And it's just like what you do at school. You've got, 12 subjects that you do? You have an hour in one, and then you go to an hour in the next, and then you have a break. And then you have an hour in one, and then you have an hour in another, and then you have lunch. You split your time so that from your perspective, you're only doing one subject at once. But if you step back from it in 10 years' time, you look back on school and you think, I did all of those subjects at the same time. How did I manage that? Describe the features of round robin. So we're looking at different scheduling algorithms and what paging is and why it's necessary. So remember, let's put this in context of what an operating system does. It has to manage processes. What are processes? Well, Control-Shift-Escape won't work for you, but it'll bring up a task manager for you at home. And it's a list of all your processes. And my laptop's going to struggle here to show all of these because it hasn't got a huge amount of memory. Every process, every program needs some CPU time, and you can see my bloated laptop has a lot of processes running. What do I actually have on this laptop? How many cores do I have? Well, I have a CPU with 4 cores. Each core can do 2 things at the same time. So I can do 8 things at once, but I have multiple processes. I'm not going to count all of these, so I can't execute them all in parallel at the same precise moment of time, but I can pretend to execute them concurrently by sharing the CPU time between all of them. That's what we mean by process management. And we put that in context as well of the operating system also has to manage files, manage users, and we don't think we've got to peripheral management yet. That's probably going to be next week. So that's what we've already said. A process means a program, a thing that you've got to do. Some are visible, like they're on my taskbar, and some aren't. Some are background processes. But they all need to be responsive, as in it needs to respond to user input. So you can't just do the whole of Word first, and then when you finished Word, only then do you update your notifications, because then you're going to miss all the notifications whilst you're working in Word. So multitasking, most operating systems are multitasking operating systems. Not all. Old-fashioned ones like DOS or even Windows 1, 2 and Windows 3 to a certain extent could only do one thing. But modern operating systems from Windows 95 really onwards could do multiple things at the same time. And we call that multitasking. You know what multitasking is because if your parents tell you to tidy your room and your teachers told you to do your homework, but you really want to listen to music, you try and do all 3 at the same time. Some people are better than that than others. So it's the operating system's job to make sure we share the the CPU time with all of the software. So an individual core on an individual CPU can only fetch, decode, and execute. Remember, the fetch, decode, execute cycle can only do one instruction at once. So it can only deal with one process at once. But if you've got multiple cores, you can do multiple processes. One core can do one process. I've showed you this already, don't need to do that anymore. All right, here we go. Here are some scheduling algorithms. So we can have first in, first out, shortest job first, or round robin. So we're going to look at some examples of these. So in your Word document, you should have a list of tasks like eat breakfast. I'm actually going to get dressed before I eat breakfast. Get dressed, eat breakfast, cycle to school. Well, actually, before I eat breakfast, what is my morning routine? I get dressed, make tea, pray with Mrs. Dring, go to shed to play the drums, listen to the Bible, play the drums at the same time, make breakfast with the boys, eat breakfast, cycle to school, and then lesson 1, and then lesson 2, and then break, and then lesson 3, and then lesson 4. Sometimes lunch, all depends on the confusing timetable, but I'm going to just assume it's that. And then lesson 5, and then off in an after school club, and then marking, and then, well, admin / email happens all of the time. So I'm not going to do this in terms of like from start to finish, but I have to do admin and email all of the time. I have to get home, eat tea, bath time, put the boys to bed, more marking / admin. I'm going to include that all up there. And then eventually, some relaxed time and some sleep. So those are all of my tasks. First of all, if we ignore the duration, how long each one takes, we could do a round robin. So round robin is going to say, all right, I've got all these things to do. I could spend 10 minutes getting dressed. And if it takes me longer than that, I'm just going to stop. And then I'm going to spend 10 minutes making tea. Well, that's probably enough because making tea only takes me 2 minutes. But I'm going to allocate up to 10 minutes. And then I'm going to spend 10 minutes praying with Mr. Dring. It probably takes about 10 to 20, so I'm going to do half of that. Bear in mind, I've got fully tea here, but I'm only half dressed. Probably not a nice mental image for you. Playing drums normally takes me 20 minutes, but I'm only going to have 10 minutes because it's a round robin. Then I can only make half of the breakfast because I'm only going to allocate 10 minutes in my round robin scheduling algorithm. Oh dear, I can only cycle halfway to school. That's a bit of a problem. So at that point, I'm going to do the first 10 minutes of lesson 1, followed by the first 10 minutes of lesson 2. But I do get the first 10 minutes of break time. Do you get the idea? Round robin means you spend up to a certain amount of time. Why am I saying 20 minutes only for lesson 1? That'd be amazing. Imagine if your lessons were only 10 minutes, 20 minutes each. Lunch, sadly, is it 45 minutes now? I can't remember, sadly. After school club, an hour. Marking, my goodness, takes ages to say an hour. Admin, yeah, maybe an hour a day. Cycle home, thankfully only takes 20 minutes. Eat tea, oh, I like that. Let's give it half an hour. Bath time, half an hour. Relax, have an hour. Sleep, oh yeah, lots of time for that. Don't know. 8 hours, 8 times 6 is 48. So let's say 48, 480. That's about right, isn't it? So round robin means that you're only going to spend a certain amount of time on each task. Shortest job first means, well, I would like to choose what I can do fastest. So at the beginning of the day, I'm going to make tea first because that only takes me 2 minutes. And then I am going to do all the 20 minutes. Oh, sorry, no, I can get dressed after I've made tea. And I can pray and play drums, and make breakfast and cycle to school. And then I'm going to have a break. And then I'm going to cycle home again. Then I'm going to eat my tea and do bath time with the boys. And only then am I going to bother with lesson 1, 2, 3, 4, 5, do my marking, and then I can sleep at the end of the day? So that's what shortest job first means. You sort your list, and you get the shortest one done first. First in, first out means you kind of do it in consecutive order. If this is the order that I need to do it, somebody gives me a task, and I don't know, Mr. Lewis pops in and says, "Sir, please can you, I don't know, make a video or something?" I'll say, "Well, yeah, add it to the list, but I'm only going to do it after I've finished, because I'm going to get through all of them first." So those are your algorithms. So first of all, please, I would like you to describe each of these. Round robin means allocate a set amount of time, up to a set amount of time to do each one, and then rotate between them. Shortest job first means sort them based on how long you think it's going to take. Do the shortest one first and the longest one after. First in, first out means you've got this queue, and then whichever job you were delegated first, that's the first one you do. Okay, so I can see some people have finished your description. What I'd like to move on to, it's going to be quite hard to apply the scheduling algorithms to your daily routine because some of these have to go in order. So instead, get onto class charts and make a list of the homework that you've got to do this week. So let's have a task. Even if you've done it, you can add it to the list if you like. And then a guess of duration. So it could be, I don't know, you've got some English to do that's going to take you an hour. It could be that you've got to get a new computer science homework. I don't know how long those normally take you. Let's say 45 minutes maybe. Plus the extra time at the end of doing your CT or your P homework, you're going to spend doing a little bit of revision or doing the Computer with Code UK stuff. So we'll put that up to 60 minutes as well. Some of the tasks might be really simple and only take you 10 minutes, but try and make a list of at least 5 bits of homework on class charts that we can apply these scheduling algorithms to, please. So let's have a look. You'll hopefully have something that looks a little bit like this. This is a list in the order that I've been imaginarily set some homework. So the English teacher got in first with an hour job, then computer science got in second with another hour, and then maths, and then physics, etc. I'd like to do half an hour of revision. I've got this big biology bit of coursework to do as well. So let's work through each of the algorithms. So round robin, what would that look like? Well, if we allocate a certain amount of time per job, first we've got to choose a certain amount of time. If it's an operating system and we say, right, I'm going to work for a day on Word before switching to PowerPoint, the user's going to get fed up because the mouse isn't going to move for that whole entire day. You want to choose something small, like, I don't know, that's why I said 64 milliseconds. So you do a bit of calculation for Word, and then you give control back to Windows, and Windows can move the mouse cursor, or switch to PowerPoint and do the background tasks there, or something like that. So if it's us, let's say 20 minutes at a time. I'm going to do English, 20 minutes, which means that I've now got 40 minutes left. Then I'm going to do computer science, and I'd like you to do this as well with your own examples. I'm going to do 20 minutes because in round robin, you go up to the amount that you need. So I had 60, I've got 40 minutes left of computer science to do. Then I'm going to do maths, spend 20 minutes on it, and I've got nothing left to do now. I've finished all the maths, that's nice. And I'll do physics, I'll do 20 minutes. Most of those 20 minutes is learning how to spell physics properly. There we go. I've only got 10 minutes left. I make a start on that big beastie biology coursework. So I spend 20 minutes on it, and I've still got 100 minutes left. French, there's no point me having all of 20 minutes on it because it's only going to take 10 minutes. So your CPU is not sat around keeping the whole computer waiting because you've got that time available. A process can say to the operating system, yeah, I've done everything I need to, just do whatever you need to do. Then I can do some revision. Oh, I can't spell today. Revision. There we go. 20 minutes of revision. I've got 10 more minutes left to go. And at that point, it's round robin. It goes back again to English. Because English has got 40 minutes left. So now I've only got 20 minutes left because I've done another 20 minutes of it. Do you see what I'm doing here? I can do another 20 minutes of computer science. So I've only got 20 minutes left. And then, have we got any maths left? No, so there's no point doing any maths. We don't need any processor time for that. Physics, well, I've only got 10 more minutes left to spend. So I might as well only spend 10 minutes on physics. Does that make sense? Biology, ooh, plodding on away at that big beastie coursework, etc. I don't think we've got any French left, have we? Hooray! Don't have to do that. I've only got 10 minutes left of revision to do. So round robin does work. It's fair. Every process that the operating system is responsible for will get a fair allocation of time. So that's an advantage, isn't it? It's simple. It's easy to implement. All you do is keep track of what your tasks are. I'm not going to bother doing any more. I'm going to finish English and computer science now, I think, aren't I? 0 and 0. Don't need that anymore. Don't need that anymore. And then, eventually, I've only got my large tasks left. How much more do I need to do? 80 minutes. So 20, 40, 60, and 80. Eventually, my round robin has finished, and I've finished all of my homework. So advantages of round robin, it's easy to implement, which means the operating system isn't spending ages trying to work out what to do next. It just allocates a certain amount of time, moves on to the next one. We talked about the disadvantages. There is a little bit of overhead. The operating system does have to interrupt a process, and then it has to resume it later, and then it has to switch control to something else, and that takes up some processor time. Not a lot, but some. And another one is, well, it takes no urgency into account. As in, if you've got a big deadline, let's say this, where's it gone? The biology is going to take 2 hours, but it's due tomorrow. Well, if you do round robin, you're probably not going to get it done by tomorrow. So you want to prioritize in terms of what's urgent. But it is fair and it is simple. Shortest job first means that you can write it out if you want. I'm not going to make you do that unless you have time at the end. We'll do that for the extension. You do your shortest job first, and then your next shortest job first, and then your next shortest job first. It's really efficient in terms of maximizing the number of jobs that you can complete. So if you're a supercomputer and you've got a whole university of staff submitting jobs for you to do, and you get your funding based on how many jobs you can complete per day, then shortest job first is going to be brilliant because you've got tiny little jobs. You can get thousands of those done, millions of those done. Problem is, somebody comes along with a huge number crunching job, and it's always going to get pushed off and pushed off and pushed off because it's never going to be the top of the queue. Does that make sense? So it's not very good for prioritizing. Also, disadvantage of shortest job first, you're constantly going to sort your list. You constantly got to work out, well, what is my shortest job? And remember, searching and sorting algorithms, that takes effort. The operating system's constantly got to work out what's my shortest job. There's more overhead for shortest job first than there is for round robin. What do I mean by overhead? I mean extra effort for the operating system to do behind the scenes. First in, first out means whatever's delegated first gets done first. Lots of people do this for their homework. So first in, first out means whatever's delegated first gets done first. Problem with that, again, there's no sense of prioritizing. It's good because you'll eventually get through everything, but let's say that biology was given to you first. You spend all of your time doing that biology coursework and the deadline's not for 6 months. And whilst you're working on it, you're not able to do any of your other homework. It's not very efficient. is very simple to implement. It's going to be faster, less overhead compared to shortest job first, because you don't have to sort anything. You've just got to shove it in an ordered data structure like a list or a queue. It's really easy to implement. It's fast, but it's less efficient. So I think that's basically all we need for today. Your extension is to, well, once you've written advantages and disadvantages in the description, is to do what I've done here for round robin, but do the same for shortest job first and first in, first out. Just check that there aren't any more slides. I don't think so. We'll leave the summary slides up on here so that you've got them. Round robin is balanced throughput. What on earth does that mean? It means the number of processes completed over time. So it doesn't mean that you're going to get loads of jobs done at the beginning and not many jobs at the end. You're constantly switching between tasks. The average response time is good. Now, I haven't talked about this yet. Response time means how long does a process have to wait until it gets some CPU time. And if response time is long, the user complains because it's laggy. As in, if you're playing a first-person shooter and then round-robin scheduling algorithm allocates the next second to installing updates, you're going to have to wait a second before your first-person shooter updates. You don't want that. You want a good response time. But if the number of processes is high and you've got hundreds of processes and you're round-robin in between them all, well, you want more CPU time for your first-person shooter. You don't really care about checking if Google Chrome is up to date or checking your antivirus definitions is up to date. You definitely want to do that, but not whilst you're playing your game. You don't want to have to go through all of the processes. It's bad. So if there are lots of processes, it can take a long time. The response time is going to be high. Big advantage, processes can never be starved of access to hardware, which means, remember if you had that huge bit of biology coursework and you're doing shortest job first, you're never going to get to it. It's the same with a operating system. If you do shortest job first, there's this big job waiting to be done. Well, round robin means at least it will get plugged away at bit by bit. Shortest job first then. Average wait time is low. Depends really, doesn't it? Response time for short processes is very fast. Yeah, short jobs will get executed quickly, but longer jobs, you've got to wait a long time before they're going to happen. You could argue that's an advantage because you want your long jobs to be done overnight. Sometimes this is a helpful algorithm. And lower overhead, there's less that your operating system has to do in the background, like sorting. I probably disagree with that, to be honest. But in round robin, you're constantly interrupting a process and giving control to another one. That's what this is talking about. There's less of that overhead. But there is more overhead in terms of having to sort your list of jobs. Big disadvantages, well, sometimes you don't know how long a task is going to take. It's like when you open up Word, the user doesn't say, I'm going to be using Word for 6 hours or 6 minutes. You don't know how much CPU time it's going to need. And then FIFO, first in, first out. We do a lot more about this and variations of it at A level. This time we don't have to sort the list anymore. It's going to be faster. You're never going to have to be pushed down the priority list because a shorter job appears. It's fair. The order it arrives in, the order it gets. I think of a bus queue in terms of first in, first out. The first person to arrive in the bus queue should be the first person that gets onto the bus, which is fair, isn't it? But throughput, that means the number of jobs per second or per minute or per hour or whatever, can be long because, can be low because you might be doing all of that biology coursework for 2 whole hours. You're not interrupted like you are at round robin. You've got to wait for the whole thing to finish before you move on to the next one. So it's completely varied. Response time and completion time all depends on how long the jobs take. There's no prioritization. Some things might miss their deadlines because you're working on a really long task. Bear in mind, some processes might have crashed. They might be stuck in a forever loop. While true, print hello. In Python, that's just going to run forever. If you did that in a first in, first out, no other process on your operating system is going to get any CPU time. It's just constantly displaying a hello world message. Shortest job first, same. You'd never actually run that really long Python program, but round robin would be the only one that copes with that properly, because that while true hello would be displayed for a little bit, and then you go off and do something else, and then you come back and do some more. So this isn't in your Word document, but it's worth pointing out. You have to manage your memory as well as the CPU time. Every time you switch between the process, you have to put the code into your RAM. So let's go back to our Word document here and think about it in terms of desk space. I have limited desk space where I work. I wouldn't be able to put all of my English homework, all of my computer science homework, all of my maths and physics and biology and French. I can't lay them all out at the same time. I've only got limited desk space. So what happens? Well, I store them all in my bag. That's like my hard disk. And when I want to work on them, I take the one I want to work on out and put it on my desk. It's like my RAM. RAM is fast, it's instant, it's available. Hard disk is large, permanent, but a bit slow. And then when I finish doing it, I might leave it on my desk and move on to the next one. So I've got English and computer science on my desk. But at that point, I haven't got any room on my desk for maths. What do? Well, I tidy up. I put English away in my bag. I might even put computer science away in my bag so I can work on physics and then maths. Do you get the idea? This is what we mean by swapping. This is why your computer will slow to a crawl if you don't have enough RAM. Because your hard disk will constantly be paging in and out. What does that mean? Well, your operating system will split your RAM into pages. Pages are fixed sized things like pages of a book, and it will say, right, Word needs 27 pages and PowerPoint needs 422 pages or however much. And then when you need to run a process, you put all of the instructions and the data into RAM so it can run quickly. And if you haven't got enough pages available in RAM, well, you take something that's in RAM and you shove it back on the hard disk. Sometimes you run out of RAM because we run out of space on our desk when we're doing our homework. If we run out of space in our RAM, then the operating system will pretend it's got more RAM by making the hard disk work as RAM instead. So it just moves the pages of RAM out of RAM and shoves it onto the hard disk. And remember, your RAM might be 1,000 times faster than your hard disk. So getting more RAM is going to speed things up massively, especially if you have multiple programs open at once. And if you replace your hard disk with an SSD, it's going to speed things up massively, especially when you're opening multiple programs because of all of this paging in, paging out. Come back to this a little bit later. Your job today, make sure that you've got description, advantages and description all sorted, and then try and work through each of the algorithms with the worked example up. Okay, so when you have finished the Word document, do save it please, and then upload it to Half Term for Computers 2, and you should be able to see your scores on there for any previous Word documents, so you can make some improvements if you've got time.